All right, guys, I hope we are ready to learn some calculus today and you're feeling good and your day is going okay. Today's going to be a little bit different in that we are focusing on refining some skills that we learned the last class. And so a lot of this video you should be able to, unlike last video, which was fairly long, and there wasn't as much to skip over, today's stuff, because people will have quite a bit of knowledge coming in, there'll be lots of opportunities to skip over some things if you're getting the answers right. So really focus on getting answers right today so you can skip over as many of the explanations as you don't need. Okay, let's get into this. So we're going to start with a question. This is a very AP style question where they give you three things. You need to decide which ones of them are true, and the answer format is like this. This is pretty common. So here's m of x, a graph. Which of these statements is true? The domain of m of x is -8 to 5. The range of x is -4 to 3. Or there are three values of x where m of x equals -1. Is it only the first statement, only the second statement, only the third statement, 1 and 2, or 2 and 3? Go ahead and answer that and we'll look at it. So the domain of m of x is -8 to 5. These are all the possible x values. And so does the domain go from -8 to 5? And of course, this means all the values in between this are defined. So I'm going to start at -8 and go. And the first thing I notice is -5. Is that a problem? Well, no, there is a value here at -5, and so that is part of the domain. Go here. I see another hole, but again, it's part of the domain because there is a value down here. Then I keep going, and I see that between 1 and 3, there are no values there. And so this is not true because there are no values between 1 and 3, and so that is not part of the domain. Okay, let's look at the range. The range is all the values between -4, this is the y values. All the values between -4 and 3 are defined. And I see there are values here from -4 up to, it doesn't matter if they get repeated. It doesn't matter if there's a blank circle here because there is a y value at -1. There are y values, if I switch over to this side, between 1 and 2. And there are y values between 2 and 3. And so all of these y values happen somewhere. And so this is correct. There isn't a single y value between -4 and 3 that doesn't happen. And the last thing, there are three values of x where m of x equals -1. So where the y values are equal to -1. So here's where y is -1. And I see one value, I see two values, but this is a blank circle, and so I only see two values of m of x where x is equal to -1, and so this is not a correct statement. And so it looks like 2 only is correct. Okay, hopefully you got that. We're going to be still using m of x here to answer these. Fill in the blanks. The limit as x approaches 4 of m of x equals, and so this doesn't have a side on it. It's both from the left and the right. So as x approaches 4, which is right here, from the left and the right, is there a y value they're both going towards? Well, the limit from the left is going towards 0, and the limit from the right is also going towards 0. And so the overall limit is 0 because both limits from the left and the right go towards 0. As x approaches something, we need to find a value for m of x that equals -1. So you need to put in a number here that makes this true. What makes this true? And so we need a limit that makes it -1. I'm going to tell you there are two really good answers and one kind of okay answer. The really good answers are -5. I'm going to put it here. -5 from the right. And this is a great answer because if you go towards -5 from the right side, you're approaching -1. Notice that I need this here because if I didn't, it would mean from both sides. And from the left, the y value is, as you approach -5 from the left, the y value is not going towards -5. And so the overall limit at -5 doesn't exist. We need it to be -5 from the right to hit -1. Similarly, we could have said x goes to -2 from the right, because as the x values get really close to -2 from the right side, the y values are getting close to -1. And there's one other place. We could also say the limit as x goes to something like 3.5 or 3.6. The reason this isn't as good an answer is because we don't know exactly what the value is here that makes it true. And so we don't want to guess 3.5 or 3.6 when really it might be like 3.67 or something like that. And so I would take all of these, but I would prefer these two because we know those are exactly correct. Whereas this one, like, it's about 3.5 and we're not exactly sure. Okay. Let's see, m of -3. M of what equals -3? So what's the x value that makes y equal to -3? And so I see there's a value at -3 here and here. And so again, just like before, I don't want an answer of -4.3 because that's not exactly right. A much better answer is m of 1. Although again, there is a value somewhere over here. It's like m of -4.3 or something, but this is like an approximate and we don't know exactly where it is, so we need to be a little bit careful there. So I would prefer this one. All right, limit of m of x as x approaches -5. And hopefully you can see that because there isn't a plus or a minus here, this is from both the left and the right, and the left limit is going towards 1 and the right limit is going towards -1, and so this limit does not exist. Okay. Limit as x approaches -2 plus. That means -2 from the right of m of x. And so as we approach -2 from the right side, we get -1. As we approach -2 from the left side, that value is -4. But as we approach from the right side, when we're a little bit to the right of -2, the value is -1. And the last question here on this graph is, the limit as x approaches what of m of x will give us -4? And there's only one possible answer here. Here is -4. We need to have the y value approach -4. And so this has to be as x approaches -2 from the left. X has to approach -2 from the left to get the y value to be -4. If we approached from the right side, the value would be -1. And if we didn't put a plus or a minus, it would mean from both sides, and that limit wouldn't exist. So that's our limits from graphs. Hopefully you're feeling pretty good about that. We are going to have a quiz on this at the end of the period. Let me make sure that's clear. We're gonna have a quiz at the end of the period. So let's look at tables. So construct a table to determine each of the following limits. And so again, we're saying limit as x goes to 3 means what? Well, it means as x gets very close to 3 from both sides. And so at the center of our table, we put in 3, and we plug in 3 here. Go ahead and do that. What is I guess we'd call this f. What is f of 3? F of 3 is undefined. Notice we use undefined for function values when we're like at a point. When we're doing a limit, as you get close, we would say limits don't exist, but function values are undefined. Because when we plug in 3, we get 0 over 0. What number should we put in that's just a little bit to the left of 3? Well, we should put something like 2.999 in for f of x, and we're going to find f of 2.999. I'm going to use a calculator trick here. I'm going to show you a couple different ways, if you didn't get this right, to do a calculator here. One thing we can do is we can just type it in on the main screen. We can do 2.999 minus 3 divided by 2.999 squared minus 9. We're just following this rule and putting it in. And we get 1.669. And that's not exactly clear to me what's going on. And so I might want to do another one. In fact, this should have been over here, and then I could put another one to the left, but that's okay. We'll do 9999. I'll do 5 9s here. And this time I'll do a different calculator trick. I'll do y equals 2, let's see, let's put in this function, y equals x minus 3. Oops. Y equals x minus 3 over x squared minus 9. If you have any calculator questions, you should be asking. And then I'm going to use this variables button. I really like it for stuff like this. I'm going to press the variables button right here. I'm going to go over to y variables. I'm going to click on the function, and I put it in y1, so I'm going to press enter on y1. And just like if this was f of x, I would put y1 of 2.999, and that'll give me this one from before. But I can also just like add on some 9s now and not have to retype stuff. You can just press like up and go highlight the thing from before. It makes it faster. And I can see this is now 1.666666. And so now it's clear that the limit, the closer I get to 3, the closer to 1.16. Oh, it's not 1.6. Guys, I hope you found my error here. This is so terrible. It's 0.1666, not 1.66, 0.1666. And we can see that it's going towards 0.166666. Hopefully you recognize what fraction that is. But if you cannot, let me tell you 2 things. One is on the AP exam, it's fine to round to 3 decimal places. And you can do it either by truncating, which means cutting off the end, so 0.166. They would accept that, although that's not what we do in any other setting. We usually look at the next number and either round it up or down. Since 6 is bigger than 5, we would round this to 0.167. So we would say the limit is going to 0.167. That's fine. That's to 3 decimal places. Or if you recognize the fraction, that's even better. If you put in enough 6s, the calculator will actually do it for you. So this is, oh, it didn't do it for me. Wow. This is 1/6. 0.16666, you might recognize or might not recognize, is 1/6. Now we need to do, that's the limit. You should recognize what limit this is. What is this limit on this side that we're doing? You should recognize that this is the limit as x approaches 3 from the left of f of x. So when we do a limit, we always have to do it from one side, and we need to check the other side. It's quite important. So what number should go be the limit from the right? Maybe something like 3.001. And so with my calculator trick, I can just go and put 3.001 here, 3.00001, good enough. And I can see it's also 1.666666, and I can, or 0.1666666. And so I can see that from both the left and the right, it is going to 1/6. So how do we write that limit overall? We write the limit, and this is f of x, the limit of f of x as x goes to 3, and since it's from both sides, we don't need a plus or a minus, equals 1/6. That's the best answer. But you also could have put equals 0.167 or even 0.166, and that would be okay. It's always okay to round to 3 decimal places. Okay, guys, do this next one on your own. What is the value that should be in the center of our table for this limit? The value should be 0, because that's the limit we're going towards. And when we plug in 0, we get undefined, because we get 0 over 0. What is a number we should pick to do the limit from the left? We should pick a number just slightly less than 0, so like negative 0.001. And when we pick a number, let's see what that is. So I'm going to type that in my calculator. I'm going to press math. Let's go put it in y equals. It'll be easier. So absolute value, the way I get to that, my favorite way to get to that is math. I press the math button right here, over absolute value of 2x over x. If you're using Desmos or something and you need help on how to enter stuff like that in, let me know and I'll try to help you out with that. And now I can use my variables. So variables, y variables, function y1 of negative 0.001. Okay, and it's negative 2. Okay, well that sure looks like that might be the limit, but let's choose one other value. Let's also check and see 0.00001. What happens when we get really close? And in my calculator, I'm going to do negative 0.0001. And that's also negative 2. And so it's pretty clear that the limit just is negative 2. What limit is this? Over here, what is this? This is the limit as x approaches 0 from the left of f of x. Okay, what's a number we need to plug in to do the limit from the right? Maybe something like 0.001. And when we plug that in, I'm just going to use my calculator here, we get 2. And I'm going to plug in one even closer, 0.0001. And I also get 2. And so the limit as x approaches 0 from the right of f of x is 2. So what does that mean the overall limit is? The limit of f of x as x approaches 0 does not exist. And it doesn't exist because the limit from the left was -2 and the limit from the right was +2. If I graphed this, okay, hold on, let me make my window go from -5 to 5, -5 to 5, good enough. If I graph this, I can see why. The limit from the left is -2, the limit from the right is +2, and the two limits aren't the same. So hopefully we can see that on the graph as well. All right, the limit as x approaches 0 of sine of x over x. What goes in the middle? Put 0 there. What's a number we should pick that's just to the left of 0? Maybe something like -0.001. So I'm going to go ahead and put sine of -0.001 over -0.001, and I get 0.999999. It is very, I don't even need to do another one here. It is very clear that this is going towards what? What is the limit from the left? The limit as x goes to 0 from the left of f of x. 0.99999 is very close to 1. And so that's already very clear. I don't even need to do a second value. Let's do the same thing, but make it positive. And we also get, so when we put in 0.001, we get 0.9999999. And so this is also the limit from the right. The limit as x approaches 0 from the right of f of x is also 1. So since the limit from the left and the limit from the right are both 1, what is the overall limit? The limit as x approaches 0 of f of x is 1. Okay. I want to point out one thing, which is that for these two, if we had just done the limit from the left or the right, we would have gotten the right answer for the first one and the third one, because the limit from the right and the limit from the left were the same. But on this one, it sure looked like the limit from the left was easy, but we had to also check the limit from the right, because if they're different, then the overall limit doesn't exist. So you do need to check from both sides. Sometimes it's a good idea to do more than one value. Sometimes you can just see after one value exactly what it is. So that's where we're at. All right, let's see how you do this. Explain in your own words what is meant by the equation. The limit as x approaches 3 of f of x equals 6. And hopefully you said as x gets close to 6 from both the left and the right, the y value gets close. Oh no. Oh my gosh, guys, what is wrong with this? What did I write down wrong here? As x gets close to 3 from both the left and the right, the y value gets close to 6. So as the x value gets close to 3, the y value gets close to 6. It is the limiting value. And we do need from both the left and the right. Okay, is it possible for this above statement to be true and yet f of 3 to be equal to 10? Explain. Is it true or not? And hopefully we said that yes, it is true. It's okay. So if x is 3 here, and the limit from the left and the limit from the right is both going towards 6. So as x gets close to 3 from both the left and the right, the y value gets close to 6. But f of 3 could be 10. That's still okay. The limit would still be 6. As you get really close, the limit goes towards 6, but the actual value there could be 10. And you'd have a graph that looks something like this. Okay. All right. Let's see. So here you're going to be graphing functions. So you're graphing functions to be able to evaluate the limit. So the idea is you just graph f of x, right? Treat this like f of x, graph it, and then see what's going on there. So let's see how you do on this. So the limit as x approaches 3 here, you should graph 4 minus x. It's a linear function. It has a slope of -1 and a y-intercept of 4. This is the same as y equals -x plus 4. And so it goes down by 1, down by 1, down by 1, down by 1. Looks like this. It's a continuous function. Yeah, it's a little ugly, but it's okay. And we're doing the limit as x approaches 1, 2, 3. So as x approaches 3, what is the limiting value? And we can see since it's continuous from both the left and from the right, the y value is getting close to 1. Okay, how about this next one? We've got limit as x approaches 2, and we've got 4 minus x, so same function, but only when x is not equal to 2. So it looks like this, except at x equals 2, we're not going to use that function. We'll use something else. Okay, so as x approaches, we're using 4 minus x everywhere where x is not 2. And when x is 2, we use 0 as our point. So here's what the graph looks like. And what is this limit? Well, coming in from both the left and the right, as we're getting close to 2, the y values are getting closer and closer and closer to 2. So the y values are approaching 2, not 0. Now, f of 2 equals 0, but the limit is 2. All right, this last one, the limit as x approaches 3 of absolute value of x minus 3 over x minus 3. Hopefully we've started to get a sense of these absolute value functions, that they've got this break in them when you're at 0 over 0. So the undefined point happens when x equals 3. And I can tell that because when I plug in 3, I get 0 over 0. So there won't be any values here. Now I just need to pick one point to the left and one point to the right. So one point to the, I don't know if you guys are familiar with this kind of function from pre-calculus or not. You may not have gotten there. 1 point to the left is, so like if I pick x equals 1. So the absolute value of 1 minus 3 over 1 minus 3. 1 minus 3 is negative 2. So the absolute value of negative 2 over negative 2. But the absolute value of negative 2 is positive 2. And a positive divided by a negative is a negative. So when x is 1, the y value is negative 1. And that will be true for all points to the left of 3. The graph ends up looking like this. You can verify that. The graph looks like this because what we'll always end up having is the absolute value of a negative divided by a negative, and the absolute value will turn the top to be positive. So for instance, if I pick x equals negative 5, I'll get absolute value of negative 8 divided by negative 8. That's positive 8 over negative 8, which is negative 1. If I pick a point to the right of 3, like 4, now I get, when I put in 4, I'm going to do absolute value of 4 minus 3 over 4 minus 3. 4 minus 3 is 1. Absolute value of 1 is still 1. And so 1 divided by 1 is 1. And so every point to the right of 3 will actually end up giving us a y value of 1. And so what is the limit as x approaches 3 here? Well, that limit is, the limit as x approaches 3 does not, I'm going to put does not exist. And the reason it doesn't exist is because the limit from the left is negative 1, the limit from the right is positive 1, and so the two limits aren't the same as each other, so that limit doesn't exist. All right, let's try a little bit more freeform, a little bit more practice on a graph. Okay, use the given graph of a of x to answer the following. What is the limit as x approaches 2 of a of x? So here is 2. This doesn't have a positive or a negative, so it's from both sides. And the limit from both sides is going to the same value, 1, 2, 3, 4, 5. So this limit is 5 because from both the left and the right at x equals 2, the y values are getting close to 5. How about the limit? This is at negative 2 from the right if you can't read it well. This is as x, I think that arrow is a little tight and hard to see. So the limit as x approaches negative 2 from the right. And so here's where x is negative 2. And as we come in from the right side, those values are getting very close to 1. So hopefully we can see that from the right side, those values are getting very near 1. What about the limit as x approaches 1 of a of x? So here's where x is 1. And the limit, it doesn't say left or right, so we need to come in from both sides. So the limit from both the left and from the right, they're both going towards 1. And notice that it doesn't matter that the actual y value is down here. Limits are about what happens when we get close, not what happens when we're actually there. A of 1 would equal -2, but the limit as x approaches 1, as you get really close to 1, the y values are getting close to 1. Okay, limit as x approaches, approaches -2 from the left. I don't know if you guys can read that well. As x approaches -2 from the left, and now we're coming in from the left side, and those y values are getting close to -1. Oh, those y values are getting close to -1. Okay, how about the limit as x approaches -1 of a of x? So as x approaches -1, there's no plus or minus, so it's from both sides, but both sides are going to the same thing. The limiting value is 4. Notice that it's continuous here, and so it's just what is the value there, because the values are going towards the, as you get close, they're getting closer and closer to the point that's actually there. So when it's continuous, the limiting value is the same as a of -1, which is also 4. Okay, last one. The limit as x approaches -2 of a of x. So this is x approaches -2. Make sure that's readable. And as x approaches -2, hopefully you see that this limit does not exist. And the limit does not exist because the limit from the left and the limit from the right are not the same. There was no left or right sign here. There was no plus or minus, so it means from both sides, and the two sides aren't coming from the same thing. All right, guys. The last one of the day for this video before you take your quiz is you're going to sketch the graph of an example function. And I would pause the video right now and try to sketch a graph that meets this description on your own sheet of paper. It's really worth trying it yourself rather than doing this as a multiple choice, which I'll also give you as a choice just to have some feedback. But pause the video and do it on your own. And now choose from which one of these matches. Okay, so hopefully you noticed a few things. I'm going to start with the f of equals because I think that's really easy to put on. F of 3 had to be 3. F of -2 has to be 1. So I put those points on there. I noticed that it is a function. If it's a function, we can't have repeating y values. So there can't be like another y value here or here or here or here, or it wouldn't be a function. That's a mistake that I sometimes see people make. Now we need the limit as x approaches, I'm going to do this one first. The limit as x approaches -2, and it doesn't say left or right, so it's from both sides, needs to equal 2. I have to put a blank circle here. And the reason I need a blank circle there is if I had 2 points here, it wouldn't be a function. So something like this and like this. Notice how I made the limit from both the left and the right go towards 2. Okay. And then the limit as x approaches 3 from the left, so as x gets close to 3 from the left side, the y values need to get close to 2. And I know I'll need a blank circle here because I can't actually have another point or it wouldn't be a function. So something like that. And then the limit as x approaches 3 from the right needs to be 4. So as I come in from the right side, the value needs to be 4. So maybe some sort of graph like this, where you only have 1 point for each x value, otherwise it wouldn't be a function. There needs to be a y value of 1 and a y value of 3 at these 2 points. But the limits need to be different. And so, does yours need to have this exact same curve? No. But did it need to match these limits? Yes. Okay. So hopefully you feel ready for your quiz and you do well. And if not, we'll adjust and figure out how to make sure you know things better. Have a good quiz. Good luck. Good luck on this. And your homework tonight is going to be a little bit different. Let me just say this now before your quiz. Your homework tonight is not practicing this skill more. It's instead practicing a skill we're going to need for next class. So it's an Algebra 1, Algebra 2 review of some of the skills you need for next class. All right. Have a good rest of your day, guys.